Hello everyone. In today's video I'm going to talk about the roots function in Mathcad Prime. I will show you how to insert it in the worksheet and how to use it to solve exponential equations. The root function is one of the many solving functions of Mathcad Prime. You can insert it in the worksheet by typing in the name of the function, and you can open parentheses to start off the argument list, or you can go to the Functions tab under Solving and you will find here the root function. Let's have a look at a few examples so you can understand how to use this function. Let's say that we have the expression f of x defined as sine of pi times x over 5.2 plus 0.84 times e to the x. To find the solution for this function, we will use the root function, and I'm going to type in the root function over here. For the first argument, I'm going to enter the name of my function, so I'm going to type in f of x. And for the second argument, the name of the variable that we want to solve for. I'm going to assign this to a variable called r0. If we use the root function with two arguments like I'm doing right now, we also need to provide a guess value for the value of x. Otherwise, we're going to end up with an error just like I did. So we're going to define here x equals 3. If we go down here, we can now evaluate r0 and we can find the first root. You can also use the root function with 4 arguments. So let's go ahead and define an r1 variable, and I'm going to assign again the root function to it. The first 2 arguments will be the same. I'm going to type in f of q. This time I'm going to use a different variable and q. And the last 2 arguments represent the interval where root searches for a solution. So I'm going to type in here -6, -2. So instead of a guess value, we can specify an interval. In this case, the second solution would be -5.192. Let's go ahead and plot the results. I'm going to go down here and insert a quick plot. And first thing, we're going to plot the function. So I'm going to say f of r versus r. Let's go ahead and update the values over here. And next, we're going to plot our solution. So we're going to say f of r0 and f of r1. And over here, we have to specify r0 and r1. We can also go to the plots tab and change a little bit the color of the traces as well as the symbols. The calculated values are represented on the plot as points at the intersection of the function plot line with the x-axis. In the second example, I will show you how to use the root function with units. In this case, we start with 2 input parameters, r and c, and we calculate the time constant. If we evaluate tau, we can see that the result is displayed in seconds. Next, I will define the function that we need to solve, and we're going to call this function v of gamma. Now that we have the function, let's try to solve it. The first step is to define a guess value. So I'm going to call it gamma guess, and I'm going to say that this is 5 times 10 to the power of -3. And we need to also specify the unit. Note that if we are solving with units, the guess values must be defined with the proper unit. In this case, we expect the result to be in seconds. Let's calculate the solution. I'm going to create a variable called gamma underscore sol, and I'm going to assign to it the root function. And as arguments, we're going to pass in the v function with the argument gamma underscore guess. And for the second argument, we're going to say gamma guess. We can now evaluate gamma sol to see the result. Let's go ahead and plot the function and the results. So we're going to put in here the plot where we have plotted the function v of gamma versus gamma and the solution. So we get the curve of the function, and the solution is the point where the x-axis intersects the curve. If we want to take this a step further, we can introduce a variable called st that is defined as a combo box over here, and I'm going to introduce it here in the root function. I'm going to say -st, And we're also going to add a new trace to the plot. So we're going to plot ST versus gamma. This way, if we change the value of ST in the combo box, we will find different rise times at which the particular voltage is reached. I will stop here for today. If you want to learn more about Mathcad, you can find more clips like this on the channel. I hope you enjoyed this video and I hope to see you next time. Thanks for watching.